Hey people, welcome back. And this session we will learn about the Kruskal Wallis test. So Kruskal Wallis test was introduced by William Kruskal and W. Wallis in 1952. Basically, this is a non-parametric test. Non-parametric test means it's a not normal data we have. And for the not normal data, if you wanted to compare the central tendency as a median for three or more than three or more than three group of data, then we perform the Kruskal Wallis test. Because for the median comparison, if you have the two sample or the two group, we compare with the Mann-Whitney test. If you wanted to compare the median of three or more than three group, we use Moore's median test. And in case you wanted to compare the non-parametric data median ranking, then we perform the Kruskal Wallis test. So what do you mean by the median ranking? Which means your overall data is divided into two parts, total data, and one will be less than overall median, and the second part will be the greater than overall median. So you will be receiving the Z median value. Z is not the sigma here. Z value will be calculated, Z statistics. If value is less than 0, is less than 0, which means the negative, then it's less than overall median. And if the Z value is greater than 0, then it's a greater than the overall median. So total median, whatever the number of groups you have, we are in the central median or overall median. And from the overall median, we'll see the sample median is less than the overall median or more than the overall median. We are dividing into two groups, and that's what the Kruskal-Wallis test will work. How? Let's take some sample data. Maybe we can take a data for the production. You have a machine A, maybe you have the machine B, let's say machine C, or maybe one more machine we have, let's say machine D. You can have anything more than three. So these four machines we have, and you are running the production from all of these four machines. You wanted to find out what is the median value or the 50% of the production are the same, or these machines are producing the different production. The capacity of the machine is different in terms of the production. We wanted to find out that. Then we'll be using the Moore's median test. So let's say machine A, I'm just taking the random number of the pieces produced by machine, or maybe the team, or maybe the person, maybe the agent, maybe the medicine effect, and anything you want to compare. Let's say this machine is, for our production, is around 22, maybe around 25 pieces. I have another machine, which is the per hour production is around, let's say 23 to 26 pieces. Another machine I have, which is producing around, let's say maybe 18 to, let's say 23 pieces. And another machine I have, the fourth machine, which is producing maybe, let's say around maybe 24 to 28 pieces. Now, I wanted to find out the median of all these machines are same or different. So for that, I have collected the data maybe for last couple of sample. So here 140 means 35. Let me make it 50, which will go around 200. And here is the last 50-hour data I have collected for the each of the machine. Production of machine A, B, C, D. 50 sample in each. Please remember, for Kruskal Wallis test, my data should be not normally distributed. Variances are equal or not equal really doesn't matter. Ideally, you should be doing that, checking, and then we compare the medians. So first thing, I assume data is not normal, but I can check data is normal or not normal by using the probability plot. So these are the four machine data production. I'll go to the graph. I check the probability. And by doing this single column selected, because each data is in each single column, and here is my data. Now, in multiple graph, you can say overlaid, separate, or maybe same panel. Anything you select, you will see the data result. And now I'll see the p-value for the first machine A is less than 0.05, which means data is not normal for the machine A. If I see the production B, p-value again less than 0.05, data is not normal here as well. If I see machine C, p-value, this is for Anderson-Darling test statistics, again less than 0.05, so data is not normal. If I see the machine D, p-value is again less than 0.05, so data is not normal here as well. We see all the four data is not normal. If you want to compare the variances as well for the not normal data, we can do. And for the variance comparison of the not normal data, we perform the Levin's test. How to do that? We'll go to Stat, ANOVA, and here we go for the test of equal variance. Click on this. You select your all data set for all the machines. Go to the options because your data is not normal. So this box we should remain unchecked because if you check this box, this will give you the p-value of Bartlett test. If you remain this box unchecked, this will give you the p-value of Levin's test. So Bartlett test we perform for the normal data and Levin's test we perform for the not normal data. So my data was not normal. I am checking the variances. So I will leave this box as an unchecked. Click on OK. Click on OK. And now if I look for the p-value of the variances Levin's test, p-value is less than 0.05, which means data is not normal and variances are unequal. And you can see the confidence interval of variances are not overlapping with each other. Though B and D is overlapping and A and C is overlapping, but A and B are different from each other or B and C are different from each other. So variances are unequal and that's how the p-value is less than 0.05. Now you wanted to perform the Kruskal Wallis test. We'll go to the stat. We'll go to non-parametric and in non-parametric, we will click here for the Kruskal Wallis test. Click here. Response O. So this is needing your Minitab. This version is asking for the stack data. So what I need to do first, I have to arrange this data. Maybe I will mark this as in production. And here I'm marking this as a machine. Right? So I'll stack this data for all these four into these two columns. I'll go to the data, stack, columns, and column. These are the four columns I'm supposed to stack. I select this. Where I will be using in the current worksheet, this is my production and the Y factor is mean machines. Now data will be arranged in this stack format and here you can see this is the production of machine A, 50 sample, then 50 sample for B, 50 sample for C and 50 sample for D. The data is stacked here. Now I will compare this. We'll go to stat, non-parametric, and here is the Kruskal Wallis test. Click on this. Response is your production and factor is your machine and just click on OK. Now we'll see the result. So you see the p-value is less than 0.05, which means the median of all machine production is not equal. You can say the null hypothesis says all medians are equal. Alternate hypothesis says at least one median is different from each other. So you can see I was telling you about the z value in the explanation. So z value is less than 0. That means those values are less than the overall median. And z values are greater than 0, which means those values are greater than the overall median. So this is my median rank. Here is the median. And here is your number of samples you have. Right? So 22 is negative and the 21 is negative. So 22 and 21, the median is less than the overall median. Where the 25 is positive 3.27 and 27 is positive 9.05. These values are greater than the overall median. So the two part I am dividing. On the lower side, I have machine A and machine C because these two values are negative. Here is the value. And on the upper side of the overall median is machine B and the machine D, which is these values are greater than the overall median. And this is the way we compare with the help of Kruskal Wallis test and we see the overall median which are the factors are less than the overall median and which are the factors are greater than the overall median. Thank you so much, people, and I'll see you in the next session.